All right, welcome. Today, we're going to unlock one of the most powerful ideas in all of programming. I'm talking about a secret weapon for writing code that's not just functional, but really, truly professional and robust. We're talking about encapsulation. So let's just dive right in. So, what do medicine capsules and great code have in common? I know, it sounds like a weird setup for a joke, right? But the answer is, well, pretty much everything. And this one simple idea, it's the key to understanding this entire topic. Stick with me, and by the end of this, you're going to see exactly how. All right, section 1, the digital capsule concept. Let's crack this thing open and really understand the big idea here. So, what is it really? At its heart, encapsulation is just all about bundling. You take some data, and you take the functions that mess with that data, and you wrap them all up together in a single neat little package called a class. But, and this is the most important part, it's also about restricting direct access to what's inside. It's like we're building these protective walls around our data. And trust me, there's a very, very good reason for it. And honestly, the best way to get this is to just think of it like a medicine capsule. Seriously, you don't need to be a chemist and understand the complex formula inside a pill to get its benefits, right? You take the capsule. That exact same logic, it applies directly to our code. Okay, let's break that analogy down even further. Step 1, the capsule itself. That's your class, the container. Step 2, the actual medicine inside. That's your private data, the really important stuff you need to protect. And step 3, the instructions on the bottle, take 2 with water, those are your public methods. They're the only approved, safe way for the outside world to interact with the medicine inside. So, that's the what. Now for the how. How do we actually build these protective walls in our code? Well, in a language like C++, we use these tools called access specifiers. And these little keywords, they are the absolute key to building our digital fortress. It's actually pretty cool how these 3 little keywords create different levels of security. You've got public, which is basically leaving your front door wide open. Anything from anywhere in the program can just walk right in. Then there's private. Think of this as a locked vault. Only code from inside that exact same class has the key. And then you have protected, which is kind of like a special key you give to close family. In coding, we call them derived classes. They get special access that others don't. And this right here, this brings us to what's pretty much the industry standard blueprint for good encapsulation. The pattern is simple. You lock down your important data by making it private, and then you intentionally create public methods to be the official controlled gateways. You're basically hiring a bouncer for your data. And what do we call this bouncer? Well, in the programming world, we call them getters and setters. They are these specialized public functions, and they have one job and one job only, to safely manage access to that private data we're protecting. Let's look at the 2. Getters, which some people call accessors, are simple. They just let you read the private data. They go in and get the value for you safely. But setters, or mutators, oh, this is where the real magic is. They let you change the data, but, and this is absolutely crucial, they get to check the new value before they change anything. A setter can say, nope, you can't set a student's mark to 150, or no way, a bank balance can't be negative. They are the gatekeepers that protect the integrity of your object. Okay, so we've seen the what and the how, but you might be wondering, why go through all this trouble? What's the actual payoff for hiding our data away like this? Well, it turns out the benefits are huge. Seriously. First off, you get data hiding. This is that security piece we've been talking about, right? It protects your data from being corrupted, either by accident or on purpose. Second, you get a massive increase in flexibility. Think about this. You can completely rewrite how a class works internally, change everything around, but as long as those public methods don't change, the rest of your program doesn't even know or care. Nothing breaks. And third, modularity. Your classes become these self-contained, reliable building blocks, kind of like Legos. This makes your entire system way easier to manage, reuse, and debug. And here's a perfect concrete example. Imagine you have a student class. The marks are private. This means some other part of the code can't just barge in and set a student's score to, 120 or -50. That's nonsense. Instead, it has to go through the public setMarks method. And that method is smart. It'll check if the new score is between 0 and 100. If it is, great. If not, it rejects it. That is encapsulation in action, making our code safer and just plain smarter. All right, let's tackle a really common point of confusion.
A lot of people, and I mean a lot, get encapsulation mixed up with another big idea, abstraction. Now, they are related, for sure, but they are absolutely not the same thing. Let's clear this up once and for all. Here's the easiest way I know to remember the difference. Encapsulation is all about hiding the implementation. It hides the messy internal details of how an object actually does its job. Abstraction, on the other hand, is about hiding the complexity. It only shows you the essential features you need to know, focusing on what an object does. Let's go back to the car analogy. Abstraction is the simple interface, the steering wheel, the gas pedal, the brakes. It's what you use. Encapsulation is the sealed engine block you never open, which protects all the complicated parts working together inside. It's how it all works.
So, as we start to wrap this up, I want you to see that encapsulation isn't just some, technical coding trick. It's much bigger than that. It's a whole design philosophy. It's a professional mindset you adopt to build high-quality software that's actually built to last. So, how do you make this philosophy a reality in your own code? It really just comes down to a few simple, powerful habits. First, make your data members private by default. Just do it. It's always the safest bet. Second, provide a public getters and setters for anything that truly needs to be accessed from the outside. And third, and you have to do this, always build validation logic into your setters. They're your first line of defense against bad data. If you can make these things a habit, you'll be well on your way to building incredibly powerful, reusable, and secure code. So there you have it. Encapsulation is all about building these strong, protective walls around our data to keep it safe and maintain its integrity. But that leaves us with one last, really important question to chew on. In our drive to create these perfectly controlled, safe little objects, when might those very same walls get in the way? When do they become a barrier to, say, performance or even flexibility? It's definitely something to think about.